Hello everyone, welcome to part 12 of my video series on the probability distributions. So in this tutorial, we are going to talk about multinomial distribution and also categorical distribution. So let's dive in. So first of all, let's understand the relationship of multinomial distribution with what we have learned so far. So for example, if you have only one view in your video and you want to know the probability of like or dislike of that video, so basically there are just two outcomes, right? Like or dislike. So in that case, you know that it can be expressed by a Bernoulli distribution, and you can find this video in part 5 of the series. So basically here we have one viewer, that means one event, and we have two possible outcomes, like or dislike. Now let's generalize this further. Suppose we have two outcomes, like or dislike, just like before, but the video can be now seen by n viewers. That means there are n events. That means there are more than one events happening, more than one viewers, and maybe m of those views are likes and n minus m of those views are dislikes. In such a case, we know that it is going to be binomial distribution. That means n events are happening and maybe m of them is success and the rest of them are failure. So here you can think of like as a success and dislike as a failure. And this is something you can find in part 6 of the video series. Now we can have another case where you have the probability of like, dislike, or neutral. So there are three possible outcomes, which basically is more than two outcomes, but there is only one viewer. So this case is a classic example of categorical distribution. That means categorical distribution is very similar to Bernoulli distribution, but the only difference is there aren't just two possible outcomes, rather there is more than two. Now, why is this so different? Because when you have only two possible outcomes, like or dislike, you can say that probability of liking the video is P and probability of disliking it is 1 minus P. But when you have more than two such outcomes, such possible outcomes, for example, here you have three possible outcomes, you are going to have to use three parameters, which are PL, probability of liking the video, PD, probability of disliking, and PN, probability of the viewer being neutral. That means he is not liking or disliking the video. So understand that if there were 10 possible outcomes, then there would be 10 parameters, 10 probability values. So this is called categorical distribution when we only have one viewer or basically one event. So the most generalized version that we are going to discuss today is the multinomial distribution. So here you can have more than two possible outcomes, which is like, dislike, or neutral, and the number of viewers can be more than one. That means it is n viewer. So it is a generalized version of all these three cases. That means greater than one viewer and greater than two possible outcomes. So this is called multinomial distribution. So I hope that this is clear so far. So now let's actually look at this with an example. So first thing is multinomial distribution is nothing but n independent categorical trials. So what do I mean by that? So independent trial means the outcome of one trial does not depend on any other trial. That means whether a particular viewer will like, dislike, or do not do anything to the video does not depend on the previous viewer or the viewer coming later on. That is independent trial. And then what is categorical? Categorical means the outcome of each trial can be some particular from some particular class, right? The outcome of each trial can be from some particular class. So in our case, what happens is a viewer can like, dislike, or do nothing. That means remain neutral to the video. That is the categorical part. So let's see an example. Suppose we have five viewers. Now two of them liked the video, one of them disliked the video, and two of them neither liked or not disliked the video. That means they are neutral. So there can be total 30 possible cases. The first two viewer may be liking the video, the third one is disliking, and the rest two, they are not liking or disliking, they are neutral. So you can multiply their probabilities together and it will look something like this if we arrange this properly. Another case can be the first viewer is liking, second viewer is disliking, then third viewer is liking, then the last two is neutral. Then again you can get the same probability after multiplying all of these. So the 30th case can be the first two are neutral, the second two are liking the video, and the last one is disliking. And again, we are going to get the same probability. Now, the first question that is coming to your mind is, how do I know that there are 30 such possible cases? This is from combinatorial problems, combinatorics. So this is how we are getting here. So from five viewers, we can choose two likes in 5 C2 ways. So after choosing the two persons or two viewers with likes, we are going to have 5 minus 2 or 3 viewers remaining. So maybe from 3 of them, one viewer is disliking. So we can choose one disliked viewer from 3 viewers in 3C1 way. So this is 3C1. And finally, after we actually like chose this viewer already who is disliking, there is 5 minus 2 minus 1 viewer remaining, and from those remaining viewers we will have to choose the two neutral outcomes in 5 minus 2 minus 1, choose two ways. So if we multiply these three things, it is going to be 30. Now this is a very basic combinatorics problem. So if you don't know about this, you can study about this as well, but this is basically from a high level point of view what's happening right here. So each of these 30 cases has a probability of this. So that means the total probability is going to be 30 into PL square into PD into PN square. Now this is an example that I've just showed. So we can generalize this within notations instead of like saying 5 viewer, 2 like, etc. So suppose we have PL, PD, and PN as probability of those three outcomes. So they have to sum up to 1 for the probability to work. And suppose the total number of like, dislike, and neutral views is n. So that means there are n viewers in total. So this is going to be the probability of these three things. So that means we are first going to choose the likes, then the dislikes from the rest, and then the neutral from the rest. The probabilities are here. This is exactly what we did before using concrete numbers. Now this form doesn't look very cool. There is a cooler form. If you do the math, you can actually reach something like this, which is very easy to remember. Basically n factorial divided by all of these factorials separately multiplied together, and then all the probabilities. Now this is just for three cases. So what about the general formula for k such possible outcomes, right? So here we have three possible outcomes like dislike, neutral. Now we can have a problem where we have maybe 10 possible outcomes. Then what are we going to do? I think you already know what are we going to do. We are just going to have n1, n2 up until nk, and again same thing for the probability. So it's quite simple, the probability mass function. And understand that this is discrete probability distribution. Why it is discrete? Because the number of events NL, ND, and NN, they are actually limited, right? We cannot say that it is 5.2 likes or 5.5 likes. You cannot say that. That is why. So next, let's talk about the expected value. So this is actually extremely simple. So let's just focus on one outcome, for example, like. So what is the probability or what is the expected value of one view being a like? It is nothing but PL, right? The probability of liking the video. And we know this from the discussion in the Bernoulli distribution video. So make sure to check out that video if you have no idea what I'm talking about right here. So here we have n views. So we can expect n into PL of them to like the video. That means expectation for liking the number of events or the number of viewers liking the video, the expectation of that is n into PL. Similarly, for the number of viewers who will dislike the video, our expectation will be n into PD, right? So that is how we calculate expectation for the multinomial distribution. For the variance, it is again very similar. If we focus on only one outcome, which is like, so for a single view, variance of like will be PL into 1 minus PL. Again, this is from the discussion we actually did from the binomial distribution video. So we actually derived this formula in that video as well. So make sure to check that video. And now since we are considering n views, it is going to be multiplied by n. So that is variance. I think the more critical one is the cumulative distribution function or CDF because there are multiple variables involved here. So suppose we have total 30 viewers. So NL, ND, and NN sums up to 30, and the probability distribution, obviously, they will sum up to 1. Now, what is the probability of likes being less than equal to 20, dislikes being less than equal to 10, and neutral views being less than equal to 5 in number? What is the probability of that? So obviously you are thinking that if we just like sum these things up from I equal to 0 to 20, j equal to 0 to 10, and k equal to 0 to 5, and just like put the formula of PMF, then that is it. That's going to actually work. So there is one problem here because suppose there is a case here where there are 10 likes, 10 dislikes, and maybe 5 neutral views. So the total number of views is going to be 25. Now, is the total number of views 25? No. So that is not a valid case. Similarly, if we have 20 likes, 10 dislikes, and 5 neutral views, the total number of views is going to be 35. But note that our total view has to be 30. So these formula, the result of this formula will be added only for those ij and k cases where the summation is 30. That is what we are actually meaning by 1 bracketed I plus j plus k equal to 30. So that's all for the CDF, and that's all for the multinomial distribution. If you like the video, feel free to subscribe and share. And you can donate to our channel through the link in the video description to support our work. Thank you very much.